You know, it's bright powder dissolving in water, so you don't want it to be very strong and shadowy and dark. You want it to be bright and fluffy looking. So I've used a lot of self-illumination there on the powder, and you can see I've got low glossiness level, and it's relatively speckly. It's got some speckle highlights on it, so you can see it comes out like this. That was just a case of tweaking around to get the effect looking good. We have this white tablet, and this is the material that's actually used on the tablets themselves. And if you have a look at this, you'll see that if you have a look at the bump map, actually what I'm also doing is I'm using a fall-off map on this particular tablet to give the edges a self-luminous effect, and that gives them a sort of more powdery look to the tablet. And then I'm using a bump map which is set to 60, and if you actually go into the map, you'll see it's got 2 noise maps. And if I just close this down here, if we actually animate, you'll see that this bump amount here animates, as you can see. And if we go over here, you'll see in this one the fractal value here animates. You can see the high value animates. And what that actually does is that actually produces a dissolving effect on the tablets. Basically, it starts off with a bump map which is very, very flat and relatively smooth. It's got a bit of noise in there just to make the surface look a bit pitted and, you know, powdery like a tablet. But this particular map then grows the high threshold, as you can see, animates and increases, and as it increases you get these big pitted effects in the tablets, and it makes the tablet look like it's actually dissolving. If you were using mental ray in Mac 7, let's say, or Mac 6, you could put that map into a displacement as well and actually have the tablet really change its shape. But in this case I found that, you know, this bump map produced pretty much a good enough effect, and it's spinning around very quickly, so you're not really going to see that much of the effect in the end. So I think it was actually good enough in this case. Okay, with that being said, let's have a look at the particle flows now. I'm not going to actually run through each one in a huge amount of detail. There just isn't enough time to go through everyone painstakingly explaining, you know, every single operator and exactly how it works. But I'll give you an example. You know, it'll show you how I approach this effect, and you can see, you know, how particle flow actually achieved the different elements. So for a start, we had 2 different tablets. This caused problems because the technique that I wanted to use was that if I actually show you how it works here, I wanted this tablet here to be birthed with these pink particles on its surface. These are what I call bubble seeds. So they basically change randomly over time. They basically get placed on the surface, and if I play the animation, you'll see that they go down with the tablet. And what happens is when they actually strike the surface, at that point, they get deleted, and they also spawn green particles. Now these particles are actually these big bubbles that you can see here. So when it strikes the surface, it spawns these particles, and these particles get puffed outwards, and they inherit the speed. You can see I've got position object here, and they're inheriting the emitter movement, and that actually makes the particles get dragged downwards with the tablet as it goes downwards into the water. So you can see you get this effect, which you can see here as they go downwards. Then what I've done is, after a random amount of time, you can see here is position object and then collision spawn. The collision spawn is when it strikes the deflector here. When it strikes the deflector, the particles get sent on to this next event. They have their rotation randomized, they have their position kept on the tablet, and they inherit the motion from it. Then they then have their speed inherited, and this then takes that motion and multiplies it, so you can see actually pushes them out much more, so they get pushed downwards. And I've used divergence on that to then make the particles spread outwards as they go downwards. We've got gravity, which is pulling the particles back upwards, as I said. In this case we're using gravity as a sort of buoyancy effect. We've got the wind large and wind small. These are producing a turbulence effect, which you've seen in many other, well, at least in the 2 other effects in this DVD, and you'll see a lot more in various other examples in future. We've got drag to slow the particles down, so you know they don't accelerate and they don't move too quickly. Drag's, you know, pretty much a constant thing in most flows. Then we test for a random age, and we're looking for an age between, you know, with a base of 10 and a variation of 7. And when they reach that value, they're then sent off to the next event. So you can see the dark green particles, which you can see here, are the bubbles which are in here, and they're sort of moving downwards. And I just use this as a sort of timing effect here.